Hello everyone. Now let's look at another LeetCode problem. This is problem 322, coin change. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. Alright, so let me read out the problem to make sure I understand it. So we are given integer array coins representing coins of different denomination and an integer amount. Okay, so coin is an array of int coins and amount. So from here you would like to return the minimum number of coin to make up that amount. Okay, so I got the problem. Let's look at example number 1. You have coins of 1, 2, 5, and then the amount is 11. Then we can take like a 5, 5, 1. So 5, 5, 1. So that will give us a 3. Second example, we have 2 and then we try to get 3. So this is impossible. Example 3, we want 1 and then 0, so we return 0. I think I got the problem. I would like to ask a few clarifying questions. Put 1. What are the length of coins? I think it's relevant to know. Here you're given it is between 1 to 12. So there are at least 1 coin, so that is good. It means the input is reasonably valid. Do I need to know anything else? Okay, so the amount. So let me put it as a range of amount. It is between 0 to 10 to the power of 4. So it can be 0. Right. Okay, I think I got the problem. And I got everything that we need here. Let me think about some possible approaches. Let me explore some possible approaches for this problem. Okay, I think I need to look back at some of the examples given there. So maybe let's take a look at example 1. If we are given 1, 2, and 5, we know that the minimum number of coins to get 1 is 1. So if we now we're going to do this. So if I write down from 0 to 11, what should I do? Okay, how about this? Because the input is small, so 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. So the minimum number of coins to get 1 is 1, to get 2 is 1, to get 5 is 1. So to get 11, the minimum to get 3 is 2, to get 4 is 2, to get 6 is 2, to get 7 is 2, to get 8. Okay, so here is an idea. We could actually look through. So base case here we have 1 to 5. And then what we can do is we add 1 coin to each of these. So if we take 1 plus 2, we got 3. So 2 here. 5 plus 1 is 6, so 2. Then see 4. 2 we got, if we take 1, take 2, then take 5, we arrive at 7. From 5 we plus 1 plus 2 and plus 5 we got 10. And then in the third loop we again repeat. From 2 we add 1 coin to each, so we got 8, add 3 coin, and then for 1, 2, 9, so 9 we can reach 9 with 3 coin. And then from 6 we add 1 coin, add 2 coin, which is 3, and then add 1 coin, which is 3. Yeah. So now we get the answer, because 11 we cannot do it with 2 coin, but we can do it with 3 coin. So that is our answer. I think this is one approach, but it will take O and array. However, I cannot think of another way that is more specific. So I think this could work. I haven't think of a solution that is much more specific off the top of my head. Mm, yeah, I think this could work. Let me try out with another example too. We have 2 and we try to reach 3. So 1, 2, 3. Now we can reach 2 with 1 coin. And then we reach 4. So basically we don't need to explore a number that is greater than our target. So there is no solution for this. Example 3, we have 1 and we just want 0, so that is 0. Okay, so I think this solution, does this sound reasonable to you? I am pretty good about this. We proceed to program unless you would like me to explore further optimization. Okay, so first of all, I think I'm gonna do this using I think can use a tag here or maybe a set. If I use a set, yeah, they can use a set, but is there a better way? So set is all one to insert and remove. So I'm thinking that if I look at the first example, I'm gonna have a data structure to store 1 to 5, and then I'm gonna pop out all of them and then add in 3, 4, 6, 7, and then so on and so on. So if I do it this way, what is the best way to do it? you could use a set and then pop the elements. And if I use a set, then I don't need to care about the duplicates, because there are many ways to arrive at a single number. Okay, I think it makes sense to use a set. So let me try that. So I think I'm gonna proceed with that. First of all, we have coins and amount. So what we're gonna do is we initialize I'm gonna use a count to check how many coins I have been using for now. Count 0. And then as a base case, I'm gonna check if amount is 0. Actually, I don't need to care too much about it if I use this algorithm. So what we're gonna do is that, hold on. Okay, so I think I need to do this because I need to differentiate between whether there is a solution or whether there is no solution. So if amount is 0, then I return the count, which is 0. Alright, so after this, I'm gonna call it a I think I can use a font set. Okay, so I turn the coins into a set. Actually, let me just call it prep. Yeah. So previously I have this, then count plus equals 1. Then what I'm gonna do is while prep, what I'm gonna do is I increase the count plus equals 1. Then I'm gonna create a curve. It's a set or an empty set. Then I'm gonna explore all the choices there. So for P in prep, P dot P prep, and then for C in coins, if so let me just call it value equals P plus C. Then if value is the amount, then we return count. Else, we put it into our current set so that we can export further later on. Cur.add the file. Okay, and then the prep would be the cur for the next loop. Otherwise, in the end, we just return -1. So let me go to the code again to make sure it can work as this method. First of all, I initialize the count to 0. And then I check if the amount is 0, then just return 0 directly. Otherwise, I'm gonna start with all the coin, just one coin, count increase to 1, and then while there is price, I increase the count, add one coin to it, then it update our current set so that in the next loop I will explore that value. Actually, I missed one thing here. So I need to check if val is less than the amount. Otherwise, if it exceeds the amount, then there is no point in exploring that possibility. Actually, I'm thinking that the set here can grow to n size. So it is actually better to just use an array and then update it. Yeah, because it doesn't. Yeah, that way it will be faster. And then another disadvantage with this is that I will possibly explore a suboptimal solution. So for example, in here I will explore 1 plus 1 plus 1 plus 1 towards the end, while it could have been just like take 5, 1 coin. And I don't need to explore like 1 coin, 5 coins or ones. So let me actually just rewrite it. So let me just cross this out and then rewrite it in the next page. So what I'm gonna do is that I will create an array called let's see what variable names I should use here. Okay, let's just call it change. And then I initialize to 0. The size would be the amount. Okay. Well done. I'm a bit confused. So if I explore 1, 2, 5, from there I can get to 3, 4, 6, 7. Actually, my previous solution might just work, except that I would need a global global font set so that I don't explore it more than once. So what I'm gonna do is that I will create a global font. So font the beginning I'm gonna call a font initialize it to empty set. Actually, I could just create the same coins. And then in the end, I will check if val is less than amount and val not in font. Then I can explore it later. Otherwise, there is no point to reconsider that value. So curve.add val, and then I need to extend the font.update. In Python, how do we let me check it real quick. In Python, how to add another set into a set. Okay, we can use update. Font update. Alright, so I think this could work. So let me go through the code again. I use a font to make sure I don't reconsider a solution multiple times. And then while there is a possible way to reach the amount, I will keep on exploring all the possibilities. So for P in prep, and then I look to all the coins. And then I check the value. If it match the amount, then we return the count. Otherwise, we add it into our curve so that we can explore it further later on. And the value has to be smaller and value has not been explored before. Okay, I think this will work. Now let me test it with our example there. So example 1, we have 1 to 5. So let me do it in the next page of my paper. So this is example 1. We have 1, 2, 5. What we want is 11. Okay, so let me make a table of count of 1. From 1 I could get to 1, 2, 5. 1, 2, 5. When count is 2, I could get to 2, 3, 6, but 2 has been explored before, so I'm gonna cross that out. And then from 2 we have 3. Actually, so 2 is there, 3 has not been explored, so 6 is also not explored yet. And then from 2 we can get to 3, can get to 4, can get to 7. From 5 we could get to 6, 7, and 10. And count is 3. We could get to 3, we could get to 4. 4 has been explored. 5 has been explored. 8 has not been explored. And then 6, we can get to 7, 8, and 11. So 11, we get the answer here. And the count is 3. So I think that worked. Now let me input my solution into LeetCode to make sure it works as expected. Count start at 0. If amount is 0, then we return the count. Otherwise, the product is a set of the coins, then found set coins, count plus equals 1, minus 1. Okay, here I just return 0. Yep. And now I'm gonna do while prep count plus equals 1, current equals set for p in prep or c in points. Gonna check file equals p plus c. If file equals amount, then we can return the count. Otherwise, what we need to do is we can check if file is less than amount and file not in font. Then we add it. Cur.add the file. I think we could also just update the font. Yep. Then after this loop, we just set the prep into the code. In the end, we return -1 because there is no solution. So let's try to run this. And we got it correct. Let me try to submit it. Hopefully I won't get like a PLE. Oops, I actually get wrong answer. Okay, so that is the edge case. Okay, how about this? I just start with 0. Start with nothing. Is 0. Yep. Then let me try to run this. If it works, then we try to submit it. Okay. So it's pretty efficient. Um, Actually, why is everyone slower than my solution? I'm starting to think that I'm actually cheating here. So coin chain result I'm gonna see is not equals to -1. I think everyone is doing the same thing. Yeah. Okay, well, I guess that's about it. Yeah, I guess we are all doing the same kind of thing. On the memory side, I'm taking much more. I wonder why, but I guess. Oh, I see. So I think I'm using a lot of set here. Okay, but I think it's still acceptable. It's not that I am using very much amount of memory. So I guess I'm gonna stop here. So thank you everyone. Okay, before I move on, just wanting to mention the complexity here is, let me go back to the question. Okay, so this would be an O and N time, and then O and space. N is the amount actually. Yep. N is the amount. M is the length of coin. Okay, so I think that's about it. Thank you everyone.